My uncle.
What?
Write this down in your notes. It's like actually an example.
Whoa, log cabinet?
A
It's a log.
Whoa, that actually is true.
And that is a true statement. This, from here, going to log cabin, is a true statement.
I started with alphabetical order.
I'm going to explain.
Oh, is that a C or a parenthesis?
This is a C up there. I put parentheses just saying that this is all multiplied
that's
together.
That's not plus or minus.
Sorry about that. So that's log of C plus log of A plus log of B plus log of I plus log of N.
Oh, base 10?
They all have to be the same base. And in my case, I just wrote log, so they would all be log base 10. But
Oh, my dad was trying to teach me.
there's a rule. How many have already done the homework? Somebody's already done 5-4? You've done 5-4? Pretty simple homework.
Yeah.
Okay, and this is one of the rules. In logarithms, okay, let me explain where this comes from. Let me ask you guys this. If I said x squared times x to the third, what happens?
X to the power
Nope.
of 6.
X
Oh.
to the fifth. Now, think about what is a logarithm. It's inverse of exponentials. That's still an exponent, right? So when I am multiplying exponents, or multiplying like bases, just like I have like bases here, what do we do to the exponents? We add them. So when I am adding logs, it's the same thing as multiplying them. Because they're the opposites. So notice here, they're multiplying, so therefore we add. Here we are adding, so therefore it's multiplying. It's the inverse. Does that make sense? Okay, this one's not the power rule, this is the multiplication rule. Okay, does that make sense to everybody though?
That has that
They all have to be a common base. So if I wrote log base 2 of 1, which is actually, I know what that is, plus log base 2 of 12, that would be log base 2 of 12. And that's a true statement as well, because does anybody know what log base 2 of 1 is? It is 0. Because 2 to the 0 is 1. And notice what's 0 plus this. This, isn't it? And that's the rule. If they have like bases, you multiply what's in there. Okay, now I'm going to tell you. What did I tell you guys about this? If you can't go from exponentials to logs, you're going to struggle, right? Or exponentials to logs to exponentials. Same thing. If you don't know this rule, you're going to struggle. So, when you see like bases and you see addition, you just multiply the parts. Okay? Pretty simple rule. But I like showing this because if you remember the log cabin idea, that shows you the rule. Right? Okay? So, once again, going back to what somebody said, if they had different bases,
Might you change the base?
okay, if they're different bases, you can change the base, that is true. Okay, if they're different bases, I can't do it. Okay? That's it. That's what it is. Is everybody with me on that? Okay. All right, so that's kind of like my example 1. Example 2, I have this question for you. X to the 6th over x to the 4th, what would that be, Tom? X squared, right? We would subtract. So therefore, in a logarithm, when I see log of x minus log of y, can somebody tell me what that equals? It is log of x over y. You just divide them. Very basic rules, right? But if you don't know exponentials, that's why they don't kind of come into it until then.
Who discovered log?
I don't know. Sorry. You Google that by yourself, though. Does that make sense, though? Where that comes from? All right. We're doing excellent. You guys are doing great. We have another rule. Yes? So if I wrote, okay, say again.
So log of x.
No, ma'am. So you're asking, would this go to log of x over log of y?
Yeah.
This is actually called the change of base theorem. And that would look like this if I had something log of yx like that. This equals this.
Okay.
That's called the change of base theorem. So before our calculators, like my calculator when I first started, which I think it's this one. Nope. Anyway, the very first calculator I have, it's not spiffy. It's just a TI-83. And like I showed you on yours, right? If I wanted to do log 3 of 5, I don't know what 3 to what power is 5. I don't. So we weren't able just to push the cool buttons like I showed you guys, like how we installed it, right? Oh, I can actually show you on my calculator. I'm on a roll today. Okay, so I don't know if this one has it. Let me check. Yeah, see, I could go to number 5 and do the
You
thing.
click on 5 on the screen right now.
Okay, and so then, like I said, 3 of 5, isn't that what I said? 1.46, so 3 to the 1.46 equals 5. I wasn't able to do that on my machine, nor is Mr. Spalding or anybody else who has an 83. Okay, you can't do it either. So therefore, we would have to go log of 5 divided by log of 3. I forgot to put 3 in front.
That definition of log.
Does that make sense? So it's the same thing. I wasn't able to, so that changed base. When I was in high school, that's how we had to solve things. But you guys actually have the adapter now. You guys can just do it. Yes.
How do you do it just normally again?
Like the way you did it, like on your machine.
Yeah.
So what I do is I hit alpha F2.
Okay.
Does that make sense?
Yeah.
That's kind of nicer way to see it. So then you're seeing what buttons I'm pushing instead of me explaining each button. So when we were doing some, like when we're equaling things, it would have been nice to see it up here, right? Okay. Anyway, you know, also can see my steps that I do. And somehow I can change my skin. Watch this. Edit. Nope. View. View. Ooh. Color. We're gonna go some blue. I got blue skin now. Anyway, awesome. Let's go on. Okay. Thanks, jerk. It kind of offends me in a little bit of a way, because that's my whole thing, is I consider myself a non-typical math teacher.
No, I mean like you're a genius.
I'm not a genius.
Yes.
I am not a genius. Okay. So are we okay so far? Now, the other rule, we have one more rule, and then we're going to start applying it, okay? The last rule is, if I had something like this, log of x, we'll say y to the third. Okay? For those that have taken this, have already done the assignment, it's fairly simple, correct? Does anybody know what rule this is? Now you can say the rule.
Power.
It's a power rule, okay? Because notice I am having something that says x raised to some power is y to the third, right? See how it's something raised to a power. Is everybody okay there? Okay, so let me ask you a question. Can somebody just tell me, what does y cubed mean? Y times y times y. So I could rewrite this to be log of x of y, y, y. Correct? You don't think so?
No, you said why?
Oh, you silly rabbit, you. Okay? With that being said, we just learned something. When we see multiplication, how could I write that again? So I could write that as log of x of y plus log of x of y, because everything I have times in here I can split apart with plus signs, right? Plus log of x of y. That's just the rule. It's basically undoing the log cabin idea, right?
Wait. So would it be a log of x of y for every single one?
Uh-huh, because notice I have log of x of y, log of x of y, log of x of y.
Okay.
How many of those do I have that are exactly the same?
So
There's 3 of them, huh?
what do you have
So
to do?
I'm going to show you. So there's 3 log x of y. Okay? Now, instead of having to go to this step, to this step, to this step, to this step, instead of being a 4-step process, what's the rule? If you ever have something raised to a power, you can just bring it out as multiplication. And that should make sense because y cubed just means multiplication 3 times. The same thing 3 times, right? And in logarithms, whenever we see multiplication, that means addition. And isn't repeated addition multiplication? Going back to our definitions back in the day when we learned multiplication, it's repeated addition, correct? So therefore, instead of having to write it 3 times, I can just say, oh, that's 3 log base x of y. Okay? Anybody question? Yes, Ethan, you good? Am I killing anybody?
Oh,
Okay, I would like you guys, now, I'm going to give you one. Log of 2 of x, y over z. I would like you guys to expand that. So how many logs am I going to have for those people that have already done this assignment? You're going to have 3. Will you guys expand this logarithm? So like, for example, log y, I expand it to be log base x of y plus log base x of y plus log base x of y. I would like you guys to loud. Okay, just talk
it's good,
loud.
it's good. Okay, so you said talk loud. Okay, so we go log, and so because am I teaching or am I just writing?
You're teaching, go dude.
Okay, so because this times this, you can break it into plus. But
So
then
he
it
sees
becomes
multiplication, so therefore when you see multiplication that becomes a positive, right?
So log base 2 x plus log base 2 of y. And then so that's this, but then the bottom, we gotta minus it, so it becomes log base.
Because remember when we divide,
Log z.
when we have division, we have to subtract.
How did people get 3 points?
Well, some people, a lot of them had plus here. But notice why could this not be the case? Because that means all multiplication, correct?
That'd be log 2 x dy.
Now, somebody had this, okay, log of 2 of x. If you wrote this, this is still technically true. But why is that not completed? Because I can still get rid of that last term, right? Yes, ma'am.
If you do log of 2, taking x plus log 2y plus log 2 1 over z?
No. Yeah, that's true, but why would I? Yes, that's true, but I'd still minus you the point.
Okay.
Because you're not in a simplified fashion. Okay?
So would you not put like 3 log?
No, because they're not the same logarithm. See how these aren't the same log? That log base y is log base z. What's up, Honcho? Hell no. I hate those things. I love an orange. I do not like those clementines.
I can find a clementine,
I love. Bye, James. Have a good one, buddy. Okay, you guys ready for another one? This is really what your lesson is expanding and condensing. That's really our lesson. So I'm going to give multiple examples of expanding, and then I'm going to have an expansion one that we have to condense it into a single logarithm. Does that make sense? Okay, I'm going to give you a rough one. Here we go. Log of... Ooh, what was it that I did yesterday? Oh, yeah. Okay, that's a mediocre one. Yep. Nope, it's 7 times the root of xy. Thank you for that clarification.
So is there like a 10 base?
It's base 10, but because it's base 10, I don't have to write it base, right?
Well, you think this guy needs 4 terms or 3 terms?
How many terms do you think?
I think 3 because
Okay, 3. How many terms? Anybody else? How many do you say? 4. How many do you say? Good. 4. Anybody else? One of those three answers is right.
No, it's not. It actually wasn't.
There is 4. 4. How is there 4? Let me explain. Notice how many terms are up there? 7, X, Y, and Z. There's 4 things, so therefore you guys split it apart to 4 different logs. So however many things are there, that's what you need to look into. Ah. I would give you 3. Very close, brother. Very close, though. I'm supposed to do what? We're going to bring it as a multiplication. You just bring the power out front. See how there's that one little step, right? But you get what I'm saying, though. Nothing can have a power. All the powers can come out front. Okay? Let's see what's another good one. Take a couple sniffs of that.
I'm so hungry.
I know, that's why I'm eating and teaching. I'm sorry. I'm sorry as well. Okay, here we go. Let's see. Let's see how you guys got it. Ooh, I love this question. This is a great question. This is simple, but some people bring this apart. How many terms?
1,
5.
She also got my for that last 5.
Okay.
No, we can't powers.
If you count powers, that's fine. I'd go a lot less than 5.
Power out first.
Nope. Can I just, no? 2. There you go. There's 2 terms.
I guess.
The same base.
Okay. Go write them. Or somebody just tell me. Let's just somebody tell me.
Wait, can I tell you? Can I try?
You don't like to guess? Hannah!
Multi-guessing.
Can I try? I don't learn that.
That's okay. Nor do
I'm
I.
getting it wrong.
Log 3 of
7
7.
plus 2.
2.
Log 3, base 3, 2x minus 3.
Because this is one term. I can't pull it apart. Right? It's one thing. But I can bring its power out. Now, Hannah, why can't I bring out the power right at the beginning? Because the whole thing was not being raised. Now, if I had an extra parenthesis in here like this, then I would bring it out. And then they both have a 2 out front of this. Does that make sense? Does everybody understand the difference there? You guys getting kind of a feel for it?
Oh, so you brought the power.
Yes. So, but these parentheses weren't originally there, right? So therefore, this is multiplication. It's 7 times this.
Yeah.
So there's the plus. Then, because he's being raised to a power 2, he gets come out front, and then I can't break him down anymore. Okay? Because I can't do 2x because it's 2x minus 3 as a single number, right? Is everybody with me on that? All right. We're doing good, guys. You're doing good.
So if the parentheses were,
If it were there, then they'd have a 2 out front of the 7 as well.
and then it would be 2.
Yes. I'm sorry you're cold. I think it's perfect.
Yeah. I think it's great.
Where? Mr. Cooper? I would wear shorts if they allowed me to.
You can't wear shorts.
I don't feel like I sometimes wonder if my attire is even professional enough. You know what I mean? Right, those are my boots. Half boots. Have you not seen the boot shoes ever?
What have now?
Ooh, this one's a good one. I like this one. Here we go. This is going to be our last expanding one, so please make sure you ask if you have questions. Oh.
to the what?
Oh, sorry, that's a 4.
Okay,
Okay? Anybody want to help me out? So sometimes this is what I like to do. Anytime I have a whole number that's to everything, I like to put a bracket around my stuff. Because it's 3 times all this stuff in here, isn't it? Because that's being raised to all of it in there. Correct? Does everybody understand that? Okay? I'm going to work with the top. Can somebody tell me another way to write x to the 5th underneath the square root?
X to the
5 halves, huh? How can I write y to the 7th underneath the square root? Y to the 7 halves. Okay? So therefore, I'm at here log base 4 of x to the 5 halves.
Could you distribute all the
I could distribute all the 3 times.
Okay.
Okay, log base 4 of x to the 7 halves. Now, anything that's downstairs, guess what you're going to have in front of it? A negative. Because even though these guys are timesing, right? Because sometimes I've seen people do this, which is correct. They go minus parenthesis log 4 of z plus 4 log 4 of w. Because that's the timesing. Z and w are timesing, right? But that negative then distributes to both of them. So anytime you have a negative, a downstairs, just have negatives in between them. Anything you have upstairs, put pluses in between them. Does that make sense what I'm trying to go with there?
Yeah, question.
Yes, sir.
In the brackets, it says log 4 x to the 7 halves.
X to the 7 halves. I'm not done with that yet.
Okay, is it
Shouldn't
supposed
it
to
be
be x to the
y?
7
Oh, why? I see what you're saying. Okay.
I don't know what that is.
Oh.
You guys did it.
And you can multiply the 3 by the 4.
And I'm going to bring them in just 1 second. Just hold off for just 1 second. So then I have minus log base 4 of z minus log base 4 of w to the 4th. Now, I can't have any power up there, can I? So they're all going to go out front, but the 3 is also going to come in and multiply by it, right? Does that make sense? Okay, so therefore this is log base 4 of x, but what goes out front of it?
3.
We're still not done.
3 times 5.
3 times 5 halves, which is 15 halves, right? Because I need to bring him out front, but this 3 is going to come in as well. You okay with that? Okay, I'm going to bring out the 7 halves, but times it by 3, that's going to be 21 halves log base 4 of y. Okay? Does this feel like a good representation of the homework?
What is the 15 over
Have you done it as well?
I didn't do it.
Now it makes a lot more sense. Minus log base 4 of z minus 12. Does everybody understand where the 12 comes in?
What?
Wait.
Would be 3.
Log
It would not be 3. Oh, this has a 3 here.
Yeah.
Thank you. Thank you.
Wait, why does that one have to
Because at first it had just a 1 here,
Oh.
but I need to bring in the power of 3 as well. And notice, think about that, guys. On a power to a power, when I have powers raised to powers, don't I multiply it in anyway? Like this is 5 halves, but this is being raised. Why does it struggle right there? To the 3rd. And when we do power to a power, we multiply, don't we? There's Coop Dog right there.
You owe me 7.
I forgot to record those. Here's the answer. Did I record this while I was talking?
I think you just really lost it.
I don't know. If I didn't, here's the step to here, to here, to here. Boom! Don't miss class anymore. Go. Okay, I'm just going to help it just so we have time, really quick, if that's okay. So what do you guys think we're doing now? Condensing. Okay, so we're going from expanded form to condensing form. So what do we see? I see some pluses and I see some minuses. Can somebody tell me what just the 2 does? How can I make that back into a logarithm? Anybody know?
2 log. No.
Negative.
It'll be ln of e squared.
Oh.
This and this are the same thing. Now why? Let me explain really quick. What's the base of ln even though it's not there? E. If it's ln, it's base e, right? Okay? So notice I'm asking e to what power is e squared? Because it had to be 2, because e squared is e squared. Right? And isn't this simplified down to 2 because e to what power is e squared? 2. Think about it. Hold on. Let me just show you. So like for example, if I wrote 3 and it came from log base 4, let's just assume. Okay? So what is that? That's log of 4 cubed. 464. It makes no sense or it makes sense? Okay, and the reason being is if you ever have this base and this base the same, here's your answer. Because 4 to what power is 4 to the third? 3. Does that make sense? Because if you put the x like we did on number 2's bell quiz, right? We go 4 to the x equals 4 to the third, and x would have to be 3. Does that make sense what I'm trying to say? So all you got to do is find the base, do the base, and then whatever the number is. Does that make sense? No? You okay? All right, so here we go. So notice I have a plus, and this is all ln, so notice I'm going to bring this power up. Ah!
Oh, that's not a 51, that's a 5.
That is a 5. This is 3/4, this is 5, right? So another way is now ln of x to the 3/4 minus ln of y to the 5th plus ln of e squared. I have rewrote it. Now, what I do now, anything that is positive, where is he going to go? Top. Anything that's negative is going to go. Does that make sense? Okay, so I have ln of x to the 3/4, y to the 5th over e. Oh, excuse me, that was wrong.
I found a cool way to remember how the number.
There it is.
So it doesn't matter which one we
Only if you have like common.
Only if they're like bases.
Yeah.
I can only do this when they're like bases. Now, I'm going to ask those people that have done the homework. Kasi, who else has done it? Jax, you did it? Do they let me keep it as an exponent with a rational exponent, or do they put me back into a radical?
They let you do this. Yeah. They do? Okay.
If, just in case, they bring it into a radical, that would be the 4th root of x cubed, right? Does everybody know how to go from exponential to radicals? So this is your root. This is your power underneath.
Down a number.
So you would go 5th root, or excuse me, 4th root of x to the 3rd. Okay? Does that make sense to you? Okay, one last example and I think we're done. Last one. Okay. Here we go. Hey, sorry I ran out of room, so let me explain, CJ. You're good.
Can I get you to sign it?
Yeah.
Because I had you sign it last year, but they didn't put me in, and you don't have a TA that period this year. So. Thank you. Thanks, bro.
Okay. Okay. Gentlemen, really quick. So I have log base 2 of 4x plus 1 minus log base 2 of 4x squared plus 3x minus 1 plus log base 2 of x plus 1. Okay? So, let's simplify this. Anything that's positive is going to go where? Anything that's negative is going to go where? On bottom. So I have log base 2 of 4x plus 1 times, what else? X plus 1 over 4x squared plus 3x minus 1. Is that my answer?
No.
Probably what are you going to have to do? Simplify by factoring the bottom, right? Now, me personally, factors of 4, so this goes into, if they give me a 4 here and a 4 here, there's a good being chance that this is 4x. And then this is going to be probably a plus 1. And how do we get to a negative 1? X minus 1. Let's try and make sure. 4x squared minus, ooh, we got to flip-flop that. We're off just a little bit. This is now a minus. That's a minus 1, x plus 1. Because 4x plus 1 is 4x, minus x is 3x, right? Minus 1. So then what simplifies out? The x plus 1. So my answer technically is log base 2 of 4x plus 1 over 4x minus 1. That's it. It's a fairly simple day. You got to remember the 3 rules. What's the 3 rules? We have our multiplication. When anything was multiplied, you have to add, right, in logarithms. Anytime we're dividing, we subtract. Anytime we have something raised to a power, we bring it out front as multiplication. Those are your 3 rules. Okay? I don't know, did they have any change of base problems? Like if they had log base 2 of 81, something like that?
Yeah.
They did? Once again, guys, if they ask you to change a base, this would be log of 81 over log of 2 or ln of 81 over ln of 2. This base has to be the same. And so on your calculator, the only bases that are the same is ln's or logs, so you can do either or. Yes, sir.
So how come x plus 1 would be, oh wait.
You okay now?
Yeah.
So, this assignment is due on Thursday at midnight so that you can go over it, get any questions you might need help from me, ask those questions on Thursday, and then it'll be due that night. So obviously it's a little bit helpful to do it beforehand, so if you have some questions I can help you. Okay? And I will change that right now just so I can remember it.